17.8 The geologic work of groundwater. Explain the formation of caverns and the development of karst topography. Groundwater dissolves rock. This fact is key to understanding how caverns and sinkholes form. Figure 17.34. Soluble rocks, especially limestone, underlie millions of square kilometers of Earth's surface, and it is in these rocks that groundwater carries on its important role as an erosional agent. Limestone is nearly insoluble in pure water but is quite easily dissolved by water containing small quantities of carbonic acid, and most groundwater contains this acid. It forms because rainwater readily dissolves carbon dioxide from the air and from decaying plants. When groundwater comes in contact with limestone, the carbonic acid reacts with the calcite, calcium carbonate, in the rocks to form calcium bicarbonate, a soluble material that is then carried away in solution. Smart Figure 17.34 Kentucky's Mammoth Cave Area. Portions of Kentucky are underlain by limestone. Dissolution by groundwater has created a landscape characterized by caves and sinkholes. Photo by Michael Collier. Mobile field trip. A mammoth cave. Caverns. The most spectacular results of groundwater's erosion.
Hello, I'm Michael Collier. Where do you think your water comes from? A spigot? A river? A well? Well, it's all true, but let's dive down a little deeper and find a better answer.
We're looking down on the Green River. It meanders through western Kentucky, eventually joining the Ohio up near Evansville. It comes out of hilly country, dissected by little tributaries that collect and carry rainfall.
But to the south there's a strange swath of land called the Sinkhole Plain where streams don't flow. Instead, the plain is pocked with thousands of depressions that swallow water before it can run into a stream. On this field trip, we'll be investigating karst topography where the limestone looks a lot like Swiss cheese, and surface water dives through those holes to become groundwater.
We'll try to answer questions like, how does groundwater flow? How do caves form? And how can groundwater become contaminated? About 3/4 of the water Americans use comes from rivers and lakes. But there's a finite supply of this surface water. In drier parts of the country, groundwater must be pumped up for drinking, for industry, and especially to irrigate crops. In fact, 94% of liquid fresh water, not ice, not seawater, but liquid fresh water, lies underground tucked inside saturated rocks and sediments in discrete pockets called aquifers. Some aquifers might be only a few acres in extent. Others are huge, lying beneath 7 or 8 states. Aquifers can hold a great deal of water, but even they are a finite resource. The most limited supply of fresh water is held within glaciers, groundwater aquifers, rivers and streams hold less than 1% of the world's fresh water. If you drill a well in south-central Kentucky, you'll hit groundwater sooner or later. Below this depth, called the water table, rocks are saturated with water. Above it, they'll likely be dry. You've got to understand, groundwater doesn't refer to just any water below the surface, but specifically water within the saturated zone beneath the water table. Groundwater flows very slowly through pore spaces between grains and rocks like sandstone, maybe inches a day or even per year. Or it can move a little faster by following interconnected fractures like faults and joints. In general, the majority of groundwater lies within these small spaces. But bedrock beneath the Mammoth Cave Plateau in Kentucky is limestone, calcium carbonate that's easily dissolved, especially by groundwater that's slightly acidic. Over long spans of time, small passages are eroded by moving water to become mammoth caves. What happens when you pull the plug on an aquifer? Well, the underground pool begins to drain out. Springs along the Green River drain the aquifer beneath the Mammoth Cave Plateau, lowering the water table to the elevation of the Green River, which locally acts as the region's base level. The Sinkhole Plain, Mammoth Cave Plateau, and Green River are tied together into a unique landscape. Why is that? First of all, this part of Kentucky is underlain by limestone, formations known as the St. Genevieve and St. Louis of Mississippian age. Secondly, the Mammoth Cave Plateau stands a few hundred feet above the surrounding country because it's capped by a less permeable, more resistant sandstone and shale layer. Thirdly, all of these sedimentary beds are gently tilted so groundwater is destined to flow north from the sinkhole plain toward the Green River. Here's where it gets fun. Surface water on the sinkhole plain couldn't flow directly into the Green River even if it wanted to, because its route is topographically blocked by the higher Mammoth Cave Plateau. Instead, rainfall drains immediately into these limestone sinkholes, and then into near horizontal caverns that pass beneath the plateau. The flow collects into a number of well-defined underground streams, like the Echo River and River Styx, that eventually return to the surface as springs along the banks of the Green River. If this was the entire story, there would only be caves at one level, all at roughly the same elevation. But the Green River is dynamic, so the story gets better. As the Green cuts deeper into the Mammoth Cave Plateau, the surrounding water table drops, and these underground rivers also shift down to lower elevations, leaving dry, abandoned caves above and creating new wet caves below. The result is a sprawling cave system, interconnected both horizontally and vertically. The result is Mammoth Cave, a huge network of passageways proven so far to be a 400-mile web worthy of being the national park that it is. Park visitors can go underground to see limestone caverns that have been dissolved by groundwater. They'll ooh and ah over delicate stalactites and flowstone deposited where water, carrying a lot of calcium carbonate, has dripped down from the cave's roof. Mammoth is only one of many cave systems in the karst of central Kentucky. Lost River Cave lies beneath the town of Bowling Green, which used to contribute at least its share of urban pollutants. Nearby Crump's Cave is on the outskirts of Smith's Grove. It lies close to the surface, collecting water and an array of agricultural chemicals that percolate down from farms above. There's always the chance that spelunkers will someday discover passages that connect this with Mammoth Cave beneath the national park. The mouth of Hidden River Cave is a downtown attraction in the nearby community of Horse Cave. At different times it's been a tourist attraction or a glorified sewer. A chrome plating factory and a creamery used to dump their waste into sinkholes that directly fed this underground river. A railroad car full of Agent Orange from the Vietnam War era derailed and spilled its terribly toxic payload downstream from Horse Cave. Rare eyeless fish that had lived in the cave for thousands of years were extirpated. The town of Horse Cave threw up its hands and seriously considered just bricking up the cave's foul-smelling entrance. But the American Cave Conservation Association stepped in a quarter-century ago and spearheaded restoration of the hidden river. Now the fish are back, and air at the mouth of the cave is fresh. The message is straightforward. Surface streams, wastewater, and groundwater are intimately, inextricably connected. We must treat them all with respect. What did you learn? The top of an aquifer is called a spring, the water table, a sinkhole. The water table is the top of an aquifer. This is Vasey's paradise, where a spring emerges from a cave deep within Arizona's Grand Canyon. If you had to guess, the cliff walls are most likely to be what kind of rock? Sandstone? Schist? Limestone? The cave is carved from the red wall limestone of Mississippian age.